Hi everyone, good morning. What's up? All good? Great. So today we will be solving the question reverse linked list. So let's see what is this question. Given the head of a single linked list, reverse the list and return the reverse linked list. How? See, we have been given a linked list 1, 2, 3, 4, 5, and what we have to return is 5, 4, 3, 2, 1. Okay, so let's see. So we have been given with this linked list and we need to return something like this. 5, 4, 3, 2, 1. So what we can do to solve is this. We can simply store all these values in some other data structure and then again change these values. Then it will be reversed. Like one way we change to 5, two way we change to 4, three way we change 3 will remain 3 as it is a middle node, 4 way we change to 2 and 5 way we change to 1. Okay. So which will be the efficient data structure for storing all these values? We can store in any of these either a vector as well. Let's say if I will store all these values in a stack. Let's say if I my head is also here and I will start a temp pointer from here which will iterate over my linked list and start storing all these values in this stack. Let's say 1, 2, 3, 4 and 5. Okay. Now I will again iterate this linked list. And what we will do? We will simply pop the top element from this check and change the value of that node. Now, then we point to the next node. Now we will again pop this value and again change this value. Now we will again pop this value, again change this value. Now again pop this value, again change this value. Now again pop this value, again change this value. In this way, we will reach to the end of the linked list. Right. So what here you can say that we have just changed the values of our nodes in the linked list, not the nodes itself. Let's say what you can see here is 2 is pointing to 1. So we have not done something like this. We have just changed their values. Okay. So let's see what how we can code it. So what we will approach is like we will be initializing a temp to head and then we will be declaring a stack st and then we will say stack of n and then while we will iterate our first we will iterate our linked list and push all the values in our stack temp value, right? And then what we will do, temp will point to the next node, right? Yeah. Now again temp will point to the head node and we will update the values in our linked list while st.empty till when stack is not empty, we will simply run this loop and temp value is equals to st.top and then we will pop that element from the stack and temp will point to the next node of the linked list, right? And at the end we will return our head. Okay, okay, cool. But what will be the now discussing about is time and space complexity. As you can see, this one loop for iterating the linked list and storing all the values in stack, and this another loop as well for updating the values. So its time complexity will be big of 2n or is equivalent to big of n. And its space complexity will also be big of n as we are using this stack extra space, right? Okay. But in your interviews, interviewer might not be happy with this extra space complexity of big O of n. Okay, so how we can reduce this extra complexity of big O of n? Okay, so let's see. So what we are doing here is you can see one we have been given with this linked list, right? Now what we have to return is we have to return is 5, 4, 3, 2, and 1, right? So you can see here is that see this note, right? Now in the original linked list, this node is pointing to 3, right? But in the reversed linked list, this second node is pointing to 1. So you can see here this, let's take another node 4. In this, you can see that 4 is pointing to 5. And here you can see that 4 is pointing to 3. So what you can see is that the node in the original linked list is pointing to the front node, but in the reverse linked list, it is just pointing to the next node. It is pointing to 3, which is its next node. And here 2 is pointing to 3, and here 2 is pointing to 1, which is its next node, right? Sorry, which is its previous node. Okay, so what we can do is, if somehow we can keep track of previous node, current node, and next node, so yeah, we can simply change the pointers because we just need to make it point like this, that our current node should point to the previous node, not to the next node, right? Okay, so let's see what we can do here. So let's say initially our previous will point to null, right? And our current is pointing to head. Okay, okay. Now what we can do is, if we can keep track of next as well, like okay, because why we are keeping track of next, because we are breaking this link and making it point to the previous node, so we have to keep track of this next node, otherwise we will lost it. Okay, so what we will do here is, we will take pointers previous, current, and one more pointer next to keep track of the next node. Okay, now what we do is, we will make current point to the next node. Cool. And we have break this pointer and make it point to the next node. Right. Now what we will do? We will make previous is make point to current, and current point to current of next. Okay. Right. Now next will become current of next. Right. Yeah. Very good. Now, what we will do? We will again make current point to previous. Okay. So we have broken this link and make current point to previous. So with this broken link will not cause any issue, because as we have keep track of this next node. Okay. Now we will again make previous point to current, current point to current of next, and next will point to current of next. Now we will again make current point to previous, and we have broken this link. Now we will again make previous point to current, current point to next, next will be current of next. Okay. Now again current will point to previous. This link has been broken. And now again previous will point to current, current will point to current of next, and next will become current of next. Okay. Now again current will point to previous, and this link has been broken, and previous will become current, current will become current of next. Okay, now if current becomes null, so what we will do? We need to return this node, and you can see that our previous is pointing to this node. So at the end, which node will we return? Previous node will be returned. Okay, because our previous were pointing to the last node, which is our head node in our reversed linked list. Right? I hope you get it. Now let's see the code part for this. You can see that if head node is null, so we will simply return head. If not, then we will iterate the linked list and then reverse the pointers. So first of all, what we were doing, we were initializing a previous pointer with null and current pointer with head. Okay. Now, till current is not null, we will keep track of the next node of the current, and then make current point to current of next point to previous, and previous will become current, and current will become current of next. Simple. And at the end, what we are doing? We are returning previous, which is our head node for now. Right? I hope you get it. I have shown you the complete dry run, this that how this code is working. We are just changing the pointer of current of next to point to its previous node. Just we are this is just the small logic for this approach. Okay, so now let's discuss its time and space complexity. As you can see, we are just using only one loop for iterating the linked list. So its time complexity we will be go of n, and as we have not used any extra space, so its space complexity we will be go of 1. Okay. So this is the iterative approach for this question. So there is one more approach for this question, which is the recursive approach. So let's see that recursive approach as well. Okay, so this is the recursive approach. So let's see what is this approach. This is also very kind of similar with the iterative approach, nothing else, just a recursive way of writing the above code only. Okay. So you can see if head is equals to null, then we will simply return head. And then again we are initializing two pointers, that is previous and current. Previous will be initialized with null and current will be initialized with head. And then I am making another function reverse in which I am passing previous and current as parameters. Okay, so let's see. Now what will be the base condition? In the ever code when we are running the loop while current, right? So what, and whenever this condition doesn't fulfill, then we will returning the previous node, right? So similarly, in the recursive code, if current is equals to null, we will return our previous node. This will become our reverse base condition. Okay. Now what we were doing? We were just storing the next node of the current and then making current next to point to previous, right? And then what we were doing? We were doing previous point to current and current point to next, right? So here you can see that we are passing previous and current as parameters, and here in place of previous I have passed current. So it means previous becomes current, and in place of current I have passed next. It means current have become next. So okay, so this is just the recursive way of writing the above code and nothing else. So what will be its time and space complexity? Its time complexity will also remains we go of n, but there is a change in space complexity because of its recursive stack space. So its space complexity will also become big O of n, right? So this was all for this question. This was a very easy kind of question. I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.